Okay, so we're going to jump right into Unit 1, which is the study of motion. And hopefully you've had a chance to have a look at those questions that I left you to sort of get you thinking about some of the applications of our unit, so kind of real life applications that maybe you can relate to. You can look at those questions now, and then we'll revisit them also at the end of the unit to kind of see how your thinking's changed from beginning to end, because each of those questions deals with a specific concept that we'll talk about in the first unit. So the first unit is broken down into two major parts. One, kinematics, and that's basically a fancy term for how things move. And two, dynamics, which is the study of why. So we're going to start off with the how, and we're going to learn a bunch of terms that are going to help us describe how things move. And once we're finished understanding that part of the unit, we're going to then come into why. So we're going to look at different things that cause things to move. So if we look at kinematics versus dynamics, two simple terms that sort of relate to each of those to help you remember. Kinematics would be more observing, and the dynamics is, which we'll come back to at the end, is being able to explain why things move, so explaining. So the first major concept we need to learn is that we can, because we're going to be dealing with numbers and quantities of things when we're talking about motion, all quantities can be broken down into two major categories. So the first category is, they call it scalar. These are quantities with no direction. And we'll look at examples to make sense of it. A vector are quantities that have a direction, and you're going to see some similarities and differences here when we start working through the unit. So for example, scalar quantities that have no direction associated with them. So we're talking direction meaning east, west, north, south, up, down, any sort of direction. So things like your age, 13 years old. There's no direction associated with that. It's 12 o'clock p.m. No direction. Weight, maybe you weigh 155 pounds. Those have no direction associated with them. They're not moving and going in any particular direction. Vectors, on the other hand, always have a direction associated with them. So if you're talking about your position, maybe you are standing 3 meters east of some point. Or if we're talking about a velocity or speed, maybe you're traveling 20 meters per second in the west direction. So when we're talking about vectors, the only thing that matters here is that there's a direction. They put it in square brackets after the value and the units are listed. And that's all you need to know about vectors versus scalar. So vectors have a direction, scalars don't. The other thing to remember, which you're going to see in a few examples coming up, is that vectors, we always put arrows on top of their symbol that represents it. So we'll show you in the next. Okay, so when we apply this concept into quantities in physics, we're going to look at the difference between scalar versus vector, because we will deal with both. So when we're just talking about physics concepts, the first one that comes to mind and we're talking about motion is, in order to know if something's moving, we need to know the distance it's traveled. And there's two different terms that we use in physics. One is scalar, one is vector. And there is similarities and differences between each. So when we're talking about when something moves, how far it's moved, the first one is a scalar quantity, and it's distance. So for each of these quantities we're going to look at, what we need to know by the end of this is what symbol represents this variable. When I say the word variable, I mean what letter is it. So for distance, we use the letter, we'll put it in red, we use the letter D. Okay, and displacement is something similar, but it's a little bit different because it has a direction associated with it. So we still use the letter D, but because it's a vector, we put a little arrow on top. And it can be a full arrow like this, or it can just be a half arrow. Sometimes you'll see in your textbook a little half arrow. So as soon as you see that arrow on top of any letter, you know it's a vector and that you know your final answer has to have a direction associated with it. Okay, so I'm going to put the symbol in red for each of these, and then I'm going to say in green, we'll put what units we measure them in. So in physics, we always stick to similar units. So each variable has its own unit that we usually measure in. So distance is measured in meters, and so is displacement. So you can see there's some similarities between them. They both use a D, they both use meters. What is the difference between them? So if you think about distance, it's the total length of the path traveled, whereas displacement is your change in position using a straight line, basically from start to finish. So if you're traveling somewhere, let's say you're traveling to school, you might use the roads or sidewalks to get from your house to school, and that's going to be your total distance. So the total length of the path that you took to get there. Your displacement, on the other hand, though, is just where you ended up in relation to where you started using a straight line. So if we were to look at an overhead view map, we look at where your house is, we look at where your school is, and we draw a straight line from start to finish. Distance is the total length of the path traveled, so it's taking into account all of the different twists and turns you might have to make depending on how you travel that distance. Okay, so time is the next one, and it is only a scalar quantity. There's no other version of time that has a direction associated with it, but it's a common thing that we're going to use in our first unit, so we're defining it here, and it's scalar. The letter that we use to represent time is a t, lowercase t, and basically this is a pretty simple one. It's how long something takes to move a certain distance. So the units for time are measured in seconds. And moving along, our last two that we're going to look at are average speed versus average velocity. Okay, again, it's just like this distance and displacement. There's similarities, but there's differences as well. And the main difference is that we're using that velocity is a vector quantity, so it has to have a direction in your final answer. And B, we're using displacement versus distance for each. So this is why they fall into the different categories. So average speed, it's a V. Average velocity, it's also a V, but because it's a vector, we have to put an arrow on top to note that it's a vector quantity and that there needs to be a direction in your final answer. Okay, so total distance divided by time. So this is actually our first two formulas we're going to learn. Okay, so both quantities are measured in meters per, so that's the per symbol, per second. Sorry about that, guys. My brain's thinking one thing and my pen's doing another. Okay, meters per second, and meters per second as well. Okay, so here's the difference. Our formulas. Average speed is equal to our total distance divided by time. And our average velocity, because it's a vector quantity, we have an arrow. And because it's a vector quantity, we have to use the vector version of distance, which is displacement, if you recall. So I'm going to introduce this new little symbol here, and it's defined for you up here. The delta symbol just means change in. And so why do we have this here? Because if you recall, displacement is the change in position using a straight line. So if you have a starting position and you have a finishing position, it's your change in position. So it's your final value minus your initial value, or the total length, the total distance from start to finish using a straight line. And velocity is so the change in position, or displacement, divided by time. So you can see there's similarities between these two. So this is formula number one if we're calculating speed, no direction. This is formula number two, very similar, but it's a vector quantity. So our final answer has to have a direction. And each of the symbols that we're using, if they're vector quantities, have to have arrows on top. Okay, so now let's look at a couple of examples of what each. So example number one, in 47.8 seconds, a sprinter runs 400 meters. What is the sprinter's average speed for this motion? So the first thing I'm going to encourage you to do when you're working through your questions, as you're reading each problem, highlight certain things. Highlight the numbers. When they give you a number, they're giving you one of the variables you need to plug into a formula. And just so you know too, you don't have to memorize any of these formulas. You're going to have a formula sheet. So all you need to do is decode what the problem's telling you. So here's our first number they're giving us. And then look at the unit that they're using. That's going to be your clue what it is they're giving you. So in 47.8 seconds, that must be time. A sprinter runs 400 meters. So there's another number with another unit. Meters is our distance. There's no direction, so we can assume it's just distance. 400 meters. What is the sprinter's average speed for this motion? So what they're asking us is to solve for v. Okay, here's our formula we're going to use. V equals d over t. So now all that's left to do is substitute and solve. So we have 400 meters divided by 47.8 seconds. And so we end up with a final answer of 8.4 meters per second. So therefore the average speed, if you can try to get in the habit of what your final answer is, put a box around it so that when you're submitting work to me and I'm marking it, you're drawing attention to what you want me to mark, your final answer. And plus if you go wrong somewhere, then I can start here and work backwards and see where you might have made a mistake. Okay, let's have a look at this example. The world's fastest coconut tree climber takes only 4.9 seconds, so here's one quantity. And as you read it, define it. So time equals 4.9 seconds to climb 9 meters up. So here's those square brackets. These square brackets tell you there's a direction. So you know now we're not dealing with distance, we're dealing with displacement. So there's a vector arrow on top of our variable, and we're looking at 9 meters in the up direction. Calculate the climber's average velocity. So now we're solving for velocity, vector arrow. We're going to use that same formula. Substitute our values and solve. So we have 9 meters divided by 4.9 seconds. And you can see where the units come from. We have a meters divided by seconds. So therefore, our final answer is 1.8 meters per second. And because this is a vector quantity, remember you have to put square brackets in a direction, and it was up. Okay, and box around your final answer, and you are done. Okay, so we won't always be given distance and time or displacement and time, so I just want to show you one extra piece of information that's going to be super useful to you throughout the rest of the course, because a lot of these formulas you'll be able to use this method. So what if we're solving for a different variable in the equation? How long will it take a cat, so let's look at an example. How long will it take a cat to run 8.2 meters north, so that is the displacement, because there's a direction, 8.2 meters north, at an average velocity. So now they're giving us velocity. So now we're given two different variables, but we're going to need the same formula. So there's two different ways we can do this. So our velocity is 3.7 meters per second north. What we're trying to find now is how long it will take. So that's time. I'm going to show you the magic triangle because a lot of people find this an easier method to rely on rather than the mathematical rearranging. You can use whatever method you're most comfortable with, but this I find is a great method. Okay, so here's where the magic triangle comes in. We're trying to find time. Every formula that has three variables in it can fit into what we call a magic triangle because it helps us solve it a little bit easier than using the math. So basically, the magic triangle tells us that any horizontal line separating two variables represents division. And any vertical line separating two variables represents multiplication. So here's what you do. Determine what you're looking for. So in this case, we're looking for time. And we're going to then cover up the variable we're looking for. So we want to find out what time is. If we cover the one we're looking for up, then we're left with the operation we have to do. So in order to solve for time, we have to take our displacement and divide it by our velocity. So that just helps tell you what the rearranged formula is. So time is equal to displacement divided by velocity. Okay, and now you're just going to substitute your values in. 8.2 divided by 3.7 and figure out what your final answer is. And what we get is 2.2 seconds. Okay, if this is a method that you've never seen before or you don't like or you're not too sure exactly if it's going to work for you, there is the other way of just mathematically rearranging, and I'm going to show you this way as well. So we have our given information here. We start out with the original equation. Velocity equals displacement over time. We are trying to solve for this variable. So we're going to use opposite operations in order to get this variable by itself on one side of the equation. So because it's being divided on this side, you perform the opposite operation to get it to the other side or up as a numerator. So if we multiply, so this is the opposite of dividing, both sides by t, because whatever you do to one side you have to do to the other. This t cancels this t out, and you write what you're left with. So you're left with displacement still equals velocity times time. And the last step is we want t by itself. So whatever's with it, we have to perform the opposite operation. Because this v is being multiplied, the way that we get rid of it or move it to the other side is by dividing it. Whatever you do to one side of the equation, you must do to the other. So if we divide this side by v, we must divide this side by v. And v divided by v cancels each other out, and you write what you're left with. So we're left with displacement over velocity is what time is equal to. So you can see this involves a few extra steps and involves you to kind of have to think and remember what you learned in math class, but it still gets you to, so this formula here is the formula that we also determined using the magic triangle. So I know most students usually find the magic triangle a little bit easier, and I will put the magic triangles on your formula sheets for your tests and quizzes. So if you think this method's a little bit easier for you, then stick with it.